Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are, I think, pretty much done with all of our memory stuff that we were doing. I was showing how to change over from fixed memory allocations to dynamic memory allocations in case people wanted the ability to use all of the same sort of style of memory use that we've been doing on Handmade Hero, but wanted to allow their programs to grow to fill arbitrary amounts of memory. So something that's like, for example, if you're using, if you're writing tools or something like that, where you don't want to say ahead of time how much memory something can take, you just want it to be able to use all the memory in the machine or all the virtual memory or anything else like that. How you write something in that style how you write something with that capabilities while still writing exactly the same style. So I showed how to do some of that stuff. We do have one bug left, however, which was that when I merged the Win32 and Arena memory block headers, something I did caused a problem with the loop live code editing save restore feature. And we need to kind of go figure out what's going on there, because that is the only thing that I know of that we are not currently doing. So I'm going to go ahead and dive in there, because that is, I think, a good to-do item for today, is to kind of finish that stuff off. Now, if I take a look at where we are here, we're on day 247. So you want to be day 246 if you're trying to follow along with the source code. And I will go ahead and load it up here, get us back to where we were. So I'm going to load in and build, and then I'm going to run. So now if we take a look at what's going on here, this is running through the Arena system at the moment, and it's doing dynamic allocations, so the arenas grow as necessary. And everything seems to work fine. And our memory footprint stays pretty stable, so we're not like leaking anything or anything like that. It looks relatively stable. It doesn't, grow without bound or anything like that. So that's a nice thing. But what ends up happening is when we go to actually do stuff with the loop live code editing, if I hit the L key, you can see that we end up, our blockchain ends up being corrupted, as far as I can tell. When we look at these source blocks, which are supposed to be strung together, what we see is that they're not coherent, right? The next pointers are not. When we loop through them, it's not creating a nice list. We end up jumping kind of off into the middle of nowhere. And so what I wanted to do is just take a quick look and make sure that there wasn't anything stupid going on, and then we gotta sit down and do a little bit more work there to make sure that everything's fine. Now, if we take a look at what's actually happening with our memory blocks here, we can see that what we've got is the platform memory block is actually a thing which keeps the information necessary for the arena itself, which includes a previous pointer, which has nothing to do with the Win32's previous chain. All that is just a thing for doing temporary memory rewinding on the arenas. So when we do like our begin temporary memory, end temporary memory blocks, arena previous is just used to walk back through dynamically grown blocks to free the ones that are no longer in use. And if we take a look over here at Win32 memory block, we have the real prev and next pointers, and those should never be touched by the arena. In fact, the only way that the arena can really ever touch those is if it was going to corrupt them in some way by doing an accidental overwrite. So for example, if we have the platform memory block here and we accidentally wrote past it, well then it could write into here. But in general, we only return this platform memory block to the arena. It never sees the fact that that was inside a Win32 memory block. So technically speaking, unless we've got an overwrite bug, a relatively severe overwrite bug there, we're not in danger of having the arena erroneously say, set the previous pointer instead of the arena previous pointer, or some other typo like that, because it never gets access to these. So we know that its code is not accessing these by name. It could only be overwriting them by accident or something like that. But what we do know is somebody at some point is doing something wrong with these, creating a erroneous, leaving the list in an erroneous setup. So what I want to do is just take a look and see if I can find it. And you know what else I want to do is I want my water. Where is my water? I'm glad I got that. That was not going to go well if I had no water this entire time. That would just be bad. So let's take a look here. So here is our allocation call. And when we do our allocation, right, this is the thing that does the checking to see if anyone has set something up to allow underflow or overflow and those sorts of things. And if so, it goes ahead and, you know, makes everything align to the memory pages in Win32 so that you get, you know, instant crashes on underflows or overflows. And that's all well and good, and we tested that out, and that seemed to work pretty well. Now, one thing that I am sort of interested in at this point, actually, now that I think about it, is we don't really know. Maybe we got the math wrong here. Maybe we did something stupid when we're setting up these memory blocks in the case where we don't do any overflow checking. Because when we do overflow checking or underflow checking, basically bounds checking, we allocate a separate page for the memory. And when we are not doing overflow checking, then we don't do that. And so what happens when we do this is if we're going to have the underflow and overflow checking turned off, we take the total size as being however much memory we're supposed to be allocating. And then we take one of these Win32 memory block structures, which we know we're going to need as sort of like an appendage to it, and we stick them together. Then we say that the offset that you're going to put the actual memory at is going to be after the Win32 memory block, right? OK. So if we're going to do that, then in theory that seems reasonable because that makes sense. We just have a memory block first, and then after the memory block we have whatever the memory is we're actually going to need. When we do an allocation here, here's the block. We do the alloc. We ask for the total size, and the total size all makes pretty good sense, right? You can kind of see here that we do exactly what we said we were going to do. We move kind of past, excuse me. We move past that Win32 memory block. Oh, by the way, since both these things don't work together, they should probably be an else. We take a look and we move past that Win32 memory block. So now we've got both the Win32 memory block and the base pointer for it. And then we take a look and see if we need to do any protecting. In this case, we wouldn't be doing any protecting. So then we're just taking a look at linking things up. We grab the sentinel here, and the sentinel, again, never changes which one the sentinel is. So we don't have to do any kind of locking around the sentinel. So we know which one the sentinel is. We get that. We say that the block's next pointer is going to be the sentinel. We remember the size, which is not, again, the size of the whole thing. It's only the size of the actual usable portion at the moment. We might want to name that something else, but that's what that is. And then we have the flags field, which is just remembering what the flags are that we actually asked for when we allocated this thing. And those are just things like that the app asked for, like don't save and restore this piece of memory or something like that, right? The looping flags, again, are just for doing things like remembering whether things were allocated during looping or not, that sort of thing. And then we have to go into our ticket lock. And the reason we have to go into the ticket lock is because if we're not inside the ticket lock, then there's no way for us to ensure that no one else is being added at the same time we're trying to add. So in order to maintain integrity of the linked list, we have to go into the ticket lock. Once we're in the ticket lock, inside that block, we can go ahead and set the previous pointer to whoever the sentinel's previous was, inserting us in the proper place to make sure that our next pointer should point to the sentinel, and then link ourselves up. Then we're outside. Again, we can exit the mutex. It's all good. And we can just return the actual platform block part to the game. Now, When we go to deallocate, you can see we're just doing exactly the same thing here. We're casting back to a block. And then we just decide either we leave the thing unfreed in the case where it's supposed to be freed during looping and we don't want to touch it, or we go ahead and free the memory block. Now, we know that only this case is really the one we care about, as far as I know. We don't have to worry about freed during looping yet because we're getting this corruption before we ever act on this flag, as far as I know. So if we go to Win32 free memory block, we can take a look at what's going on with that guy. Let's see here. Where is that? Win32 free memory block. There you are. And you can see what that does is it takes the memory block we're trying to free. It enters the mutex first, right? Because, again, it's going to have to unlink itself. As soon as it unlinks itself, then it considers itself done, and it goes ahead and releases the memory back to the system, including the block header itself. But that should be fine because, again, we've already made sure that the person who is behind us is now pointing over us to the next person, and the person who is in front of us, who is that next person, is now pointing back over us to the previous person. Nobody's pointing at us anymore. So in theory, that should maintain a linked list that does not have errors in it. But that's not what we're seeing. So the question is just what's going on here? Like, why are we seeing this problem happen? And I don't know. So what I'd like to do is step in a little bit and just see. Maybe let's step into Win32 free memory block and see. I just want to take a quick look to see what's happening when we do one of these. I'm basically trying to get a sense here. Is this a problem that happens all the time or a problem that only happens once in a while on certain memory blocks? Like how rare of a bug am I looking for? So I'm just trying to get a spot check on that. So when I step in here, I can take a look at this block. This is the block. I enter the mutex. I'm ready to unlink it. You can see that I've got a block here that's got, I don't know, reasonable size. It's a megabyte large. That seems reasonable. Of course, only 8. Only 8 bytes of it was used. Not very efficient there. So I guess it was just a little bit of extra overwrite of something. Not sure what's going on there, but it's fine. So that's something we can take a look at later. So that's all well and good. And if we take a look at the previous pointer, both the previous pointer and the next pointer, I just want to see like what looks reasonable here. It would help me if I knew who the sentinel was. So I'm going to go ahead and take a look. Global Win32 state. So you can see the memory sentinel here. I want to just get a little bit of a feel for where that is. So here's the address of the memory sentinel, and you can see that's the address right there. And so that is this guy. And we can kind of identify him because since it's static, you can see that it's got the location in the executable. So we kind of know that that's the right guy. So you can see that the next pointer is pointing to the sentinel. So this is the last memory block. And I just want to see what happens. I should probably leave this out now I think about it, because I want to see what happens when we free it. I want to make sure that the list remains in reasonable state. What I should be able to do, since this is a circular list, I should be able to walk all the way down until I get back at some point right to there it is, to the sentinel. So I can verify that my list is in fact in reasonable shape. All right, so here we're going to unlink, right? We have now unlinked our memory block. So now our blocks next and previous pointers are the people before and after them are no longer pointing to this block. And in theory, that it's okay. We should still be able to have it so that the memory sentinel, if we travel from it, we should now be able to do the exact same circular list and just see that it's got one less thing in it, right? But we still get back there. So we know that left our list in a reasonable state. So all of that looks pretty good, right? There isn't anything particularly unusual going on there as far as I can tell. And so what I want to do is I want to, rather than sit here trying to go through this and debug it all the time, I pretty much know what's going on, right? When I hit this, this loop live code editing, I know that I'm coming in here, and I know exactly what I'm doing. I'm starting at the memory sentinel, and I'm going through looking at these source blocks until I get back to the sentinel. That same process that I did in the debugger where I just kept clicking on the next thing, that's all I'm doing here. And then I know that when I look at these sizes, eventually I get to some complete garbage data here, right? I'm getting to just completely nuts data. So what I want to do is say, well, maybe if I now know, right, that I have something, and like I verified that I'm not just being completely stupid, like it wasn't like every time I unlinked one of these things I messed it up, right? So it's a little more subtle than that. What I want to do is say, well, okay, let's just make something that's called like, you know, verify memory, Win32, verify memory integrity or something like this. Memory list integrity, something like that. What I can do is just say, all right, what if I just was to copy this code exactly as it is and retain the important part of it, right? So as I come through here, basically every piece of information, or rather every block that I go through, if I was to just say, hey, it's this desk block size bit that I care about here. So let's just go ahead and take that what the desk block size was going to be, put in an assertion that is the exact same assertion that we had before, so that the block size was OK. And we'll make that be the list integrity verification thing, right? So now what I should be able to do is say, hey, right before we call that, I should be able to call Win32 verify memory list integrity, and we should crash, well, we're not crashing, we should assert there rather than in the main loop. And now we know we have a function we can call at any time that will fail if the list is in this state. So now what I can do is I can go ahead and make sure that that checking will occur whenever I can make that checking occur whenever I want. Now, there's one thing that I probably should do here, and I don't know why we weren't doing this, and that is that this list kind of needs to be checked, it kind of needs to be blocked out so that while we are operating on it, it probably shouldn't change, right? So we should probably leave our memory mutex around here where we, you know, make sure that we don't have anyone mucking with the list while we're trying to edit it. Because it's entirely possible that that could happen, even though it's probably very unlikely. So let's make sure we still get the problem, even in that case, which I assume we will. Yeah, because it was happening so routinely that I knew that was the case. But now we know we can call this anywhere we want. So what I'm going to do is I'm just going to go ahead and try some random stuff to try and provoke the error in a place that would be more conducive to catching it. So first, let's just make sure that this error happens at some point without us having to push the L key. So for example, every time through our main loop, let's just verify that memory, right? So here we go. And we trigger like right away. So now we know like when we come into this list, we've got a problem with our memory integrity, right? And you can see it doesn't happen the first time through, but it happens the second time through, right? So it happens pretty quickly. There doesn't have to be much happening before we get a memory integrity violation. So now let's say, all right, now that we know that this memory, this list is having a problem pretty early on, let's try putting something into the allocation and deallocation routines where every time we do the verification, we'll just check it whenever we do an operation, right? So anytime we call Win32 deallocate memory or Win32 allocate memory, we'll just call it as a matter of course and see if we can catch the bug that way, right? So now here we go as we run, and you can see, oops, I didn't mean to do that. Let's try that one more time. There we go. There we go. And you can see we are getting it here, and we're getting it on an allocate. So now that I know that we're getting it on an allocate, I'm going to do one more thing. And what I'm going to do here, because now, and again, this is all very standard debugging stuff, but I like to kind of explain it out loud as I'm doing it, so that people who don't know some of these techniques can be familiar with them, can become familiar with them. You can see right here when we call Win32 allocate memory, well, I come into this routine. I know that something in here, when I get to the end, I get Win32 verify memory list integrity. I get a problem. The thing is, I don't know if it was actually one of these things that caused it or some other thing that caused it, right? Because maybe it was already corrupted when I came into this function. So what I'm going to do now that I have a sort of point of failure more localized, I'm going to go and put one at the top. So now I know if the top one doesn't fail, but the bottom one does, it's something inside here that's the problem, right? So let's give that a go, and we'll see which one it is. I come in here, and now I'm seeing it's the top one, right? So I know that something outside of this the system, it's not a case of like there was a bug in this code. It's a case of between the last time somebody allocated memory and this time somebody borked our list, right? So somebody's actually doing something problematic there that we don't know, that we aren't aware of, right? Well, the other thing I can do is let's see where in the code we were. Inside allocate memory, we're in push size, load bitmap. So this is in the mainline code. We're doing a load bitmap. We're doing a push struct on a task arena. So that's actually calling one of the multi-thread arenas here and asking it to do that. And I guess I'm not sure why that would really be anything particularly odd. But point being, that's where we're having it happen, right? And when we do the verify, you can see that we've got the problem that we thought we were going to get. So at that very point in time, we have the error has occurred. And so it's somewhere in here. Now I'm going to take a look at the threads as well. And you can see we've got thread procs sitting here. The thread procs are not doing anything at the moment, right? They're all just sitting there inside thread proc. They're just waiting, and they're not doing anything useful at all. So what that sort of suggests to me, and again, not conclusively, but what that sort of suggests to me is this isn't a threading problem. This isn't the sort of situation where it's like some thread was allocating memory, and my thread did something, and those two things conflicted and weren't locked properly or something like this, so they ended up doing something bad. It doesn't look that way. It looks like something where, we got more of a straightforward kind of an error, right? All right. So I'm going to also take a little look here and see which entity are we actually processing. How far did we get through here? We're at entity number 9. So we've done a certain amount of processing before we've actually had this memory sort of situation manifest itself. So yeah, so I don't know. That is sounding a little suspicious. I'm not really sure. Let me take a quick look here. I want to look at the arena code. I want to take a look at the arena code, and I want to see how it uses some of this stuff. Let's see here. So and temporary memory, temp mem block, blah blah blah, free last block, where it calls the allocated memory, pass the memory block, which is the current block, and that's all good. Arena prev should always be set when we allocate a new one to the block in question, and it is. So that all looks, that looks fairly reasonable to me. So yeah, I don't really know why we're getting that kind of an error here. But, what we can probably do is we can probably look to see, where that thing is getting where that thing is getting corrupted. So what I want to do now is I want to set a breakpoint that will occur at the appropriate time for this. So I want to show, like, I want to just basically have a way of saying, well, I know at some point I'm going to have this memory list integrity violation occur. But I also know that it doesn't happen for a while, right? So what I can do is say, all right, let's suppose that I had some kind of a static here, right? Or maybe not. Is just global variable? There we go. I always forget what I called that in this code base. All right, so let's say I have a global variable here, and I'm just going to use this as a memory counter. This will just be our fail counter, right? It tells us when things are going to fail. And so what I can do here is I can do, an interlocked increment on this basically. And in fact, you know what? I could put it inside the verify. So what I can do is say inside Win32 verify memory list integrity, I can just say, OK, every time we go in here, we increment the fail counter. And so now we know, which one of these is the actual failing case. So let's go ahead and run it. Here is our failure. We look at the fail counter and see that the fail counter is at 35, right? That means it took 34 successful calls to the verifier before we actually had one fail, right? So what we can do then is we could say, well, OK, let's go ahead and take a look at what happens right around that time. So for example, when this fail counter increments, what I could do is say if the fail counter equals the failure case, right? So if the fail counter equals 35, give me a place to break, right? So now what I should be able to do is say, all right, here's the failure case. We know that we just validated this thing properly, right? It actually worked OK. And that we, are expecting to be able to come through here and have this thing work all right. So this guy succeeded. We got our memory back. This stuff's getting allocated. We do some things. Let's just take a look at what happens here. We're doing whatever we're doing here with our chunks, and everyone's chunking around and doing chunky things. We probably finish this routine. We come through here. We do all this nonsense with players and all that kind of stuff, right? Here we go with our brains getting their things and whatever's happening. And then we come through here, and the first time we try to do our update and render entities call here, when we try to draw something on entity index 9 for whatever reason, when we try to actually draw entity index 9, then we do that push and then we fail. So we know that somewhere in between those two things, somewhere in between the start of the sim region and rendering that entity, that's where the thing got corrupted, right? So now we've sort of marked our two areas. We know where we're OK, and we know where we fail. So now we just need to figure out who is it exactly who is getting corrupted, right? And I don't know the answer to that question. So the next thing I want to do is step into the failing one of these. So now we're in the failing one of these, right? I let it go till the 35 case. So we know this is the one that fails. So now what I want to do is say, all right, now that I know that that's the one that fails, what's the actual anatomy of the failing block? Here is the sentinel. We're going to its next pointer. And the next pointer, OK, so this is good. The very first thing off the next pointer is, this next pointer is garbage, right? So now what I can do is say, all right, let's go through here, come to the breakpoint, the part that we know we're OK. What is my next pointer? Here is my next pointer, and my next pointer looks good, right? So now I just have to figure out who changes this, right? And I know that this size gets changed or this next pointer gets changed. Which one? I don't know, so let's find out. here's the next pointer that I'm expecting is this value. Let me run to the assertion. Well, run to the next one, let's say. And let's take a look. There's the sentinel. It's pointing to the same person. So what this tells me is that there's no problem with the linked list itself. Somebody is actually stepping on the size parameter for some reason. Now I have, so hopefully you saw that whole process. I've taken a very random, weird occurring bug that we had no idea where it is, and now I know exactly what I need to do to find out who the culprit is. I know that that particular value is getting overwritten, and I know when it is getting overwritten in a bracket, right? So all I have to do is now set a breakpoint that will tell me that, and I can do that like this. I know that now I'm going to set this value is correct right here, right? I know that it's all right in my next pointer block, right? I know that that's correct. What I want to do is say, OK, where is this value in memory? Here is the value, right? So now what I'm going to do is say, let's get a breakpoint on that value. Let's tell me when that value changes, right? And probably should try and cut and paste that. There we go. So I'll say new data breakpoint. Tell me this guy right here is the thing. I want all 8 bytes, so it doesn't really matter because it's all getting modified, it looks like. But either way, just tell me about all 8 bytes and see if you can tell me when that thing gets changed, right? So let's run. Here we are. And so now we get a breakpoint that says somebody is touching that memory, and we know that they should never be touching that memory. So what just happened, right? So let's take a look here. We're inside push render element, and what we're doing is we're setting an entry that's our sprite bound for one of our entries, and we're looking at push.sort entry, right? So that's when we did one of our push buffer operations, and so something is going wrong here where we're maybe like we're maybe like using too much memory, or we don't know what's happening. But when we're trying to access this entry struct, we're like overwriting the memory, right? So we've caught this fellow now. So now let's take a look at how that happened. So when we go in here and we said, what did we say? Push buffer. And the push buffer is what gave us back that sort entry pointer. And let's see what that actually is. What is entry right here? So entry, yeah, entry is 7935. Can we get a look? Can we get a look at what Win32 global state is here? Of course we can't, because Visual. All right. So one of the nice things about Visual Studio is it doesn't show you variables if you're in the wrong module. So hold on a second. Let me see if I can. What is it? It's global Win32 state, right? So there it is. Can you show it to me here? No, you can't. All right. It doesn't matter. I'll just back up the stack to here, and it can show between. It's a global, so it's fine. So here's the global. Here's that sentinel. Here's the next pointer. And you can see the entry is literally pointing right at our memory block, right? So that's just not good, right? That is not at all a good thing. That is presumably why we were getting that error. And if we look at the base pointer is clearly pointing 40 elements past that. So the question is, how did this thing ever end up thinking that it was going to write there? And I don't know. Let's find out. How did that happen? So when we call on this push buffer here, and we do push buffer, we're going to call up in here. This is the data size that we were expecting. We say here's the commands, blah, blah, blah. We say the sprite bounds, sort entries is somewhere. And we'll have to take a look at where that is, because that's the thing that's actually failing. We say like, okay, as long as that is not in the wrong place, we'll keep going. Meaning as long as that hasn't overflowed its bounds. So let's see, get sort entries. I want to take a look at this. It would be nice if we could figure out a way to actually step through this code explicitly, but we can't we'd have to do a little bit more work to get to that point. So what I'd rather do is just see if I can't spot the error myself in this code. So if we go to get sort entries, that's at the push buffer base itself. So the push buffer base in this case is just wrong. We know that that is not what the push buffer base should be, assuming that this is the same memory layout as last time, which it might not be. Address space randomization may not be turned off on this machine. I'm not sure if it is or if it isn't. But if we assume that that's still where the sentinel is, which I can quickly verify, let's go ahead and jump back there. Global Win32 state, memory sentinel next. Yeah, 7AB 4 zeros. And I come back here and I see 7AB with 4 zeros. How did the command's push buffer base get set to a memory block header value? That's just should never have been possible because the push buffer base should not be set to that, right? That's a clearly erroneous place to write no matter what, and that's just not good at all. So where do we set the push buffer base? Let's find out. There's not very many places where we even use it. Let's see here. There's the push buffer base. Commands push buffer base. Render group, push buffer base, push buffer base, push buffer base. Hi. That is not, oh, right, I know why. Because we set it inside this little thing up here. All right. Oh. That answers that question. Man, that was a tricky one. That's because we did this stupid thing here, which was probably not the smartest idea. You can see what happened, right? When we do render command struct and we pass a push buffer here, probably what happened is we called the allocator, and the allocator returns the block to us, which is probably wrong. So I'm going to go ahead and guess that probably what should have happened here is we probably should have said something like that, at which point we would get an error. Where is the push buffer? There is the push buffer, and you can see the error, right? We do the Win32 memory allocation call, but a Win32 memory allocation call technically produces a platform memory block pointer. And really, if we want the push buffer itself, we have to get the base pointer back, right? So that's that. Oops. OK. Oh, and that's a U8. There we go. So I think that's it. And now if I do a build here, I think we should be good to go. Let's find out if we are. And there's our loop live code edit path, and off we go. And that's it. Yay! Bug is dead. So yeah, that's the bug. The bug has been eliminated. And you know, that's yeah, some stuff happened. Probably don't need this stuff anymore. But you know, it seems like all of this stuff with the fail counter and that sort of thing is probably useful. Do we have a local persist? We do. What we could do is move that in here. Just call this our own little thing, our own little, you know, situation, and then just get rid of the calls to it everywhere. But then, if we find another bug like that, we can always just call that function again and use it to track down another problem with that sort of thing, right? OK, so I think that's just about it for the memory stuff. I don't know that there was anything else in terms of implementation. What we could do now, if we wanted to, was also we could add a little bit of information to our debug display to let us know who is using memory and how much they are using, which is kind of a nice sort of just ballpark estimate to get now that we know that we have that information. So what we could do there is we could, how much time I got left? Only have 13 minutes. But, you know, I think we left ourselves in a reasonable state here with these things where I probably could do something where those kind of get displayed. Let's just take a quick look. I'm going to open up the to-do list. We did that debugging. Let's go ahead and see about this one right here, just so we can have some idea of what's going on there. What the problem that we're going to have is we don't really have any way for a memory arena to really have its state initialized with debug information. And I mean, I'm not really sure, like I said, how best to do this. Now, one thing that we can do pretty easily, if we want to, right, is I can do a thing that's just like Win32, you know, get memory stats. And it's pretty easy for us to go through all of the memory blocks and figure out what our statistics actually are, right? So I can do like memory stats, something like this, and just say, all right, you know, there's a block count, there's a total total allocated, and total used. And all we would have to do when we come through here is say, all right, let's make one of these stat structures. Let's, every time we loop, you know, over one of these blocks, we'll say, okay, there's a block, there's a total allocated, and a total used coming out of it, where we could say source block size and source block used. Now, technically, size doesn't actually include the header, but that's OK for now, I think. Let's see here. Note, Casey does not technically include the header. So this function would allow us to get a quick picture of our memory stats, return stats, that could be used by anyone for, you know, printing out memory information. Let's go ahead and compile that. We need to grab that sentinel, put that in here. And technically, since this list is accessed in that way, we would have to go ahead and mutex it as well. All right. And I think that's about it. Size. Right, because it's platform. So it's actually that, right? Yeah. So that would gather up the information that we want. And now the only question is, how do we pass it to the debug system? Here is one way we could do that. When we do the debug end frame stuff, you know, we could provide a function for getting this back. I don't like to pollute, you know, to have too much in the way of debug calls, but you know, we could have one in here. We could say something like, you know, debug platform get memory stats or something like that. Debug platform, oops, platform memory stats, and then name. And this wouldn't have to take any parameters at all. Type def, and then debug platform get memory stats, something like this. And then we could, if we're in the internal thing, have debug platform get memory stats, debug get memory stats. And that would allow us to figure out to call this dynamically. And then I would just go ahead and put that guy up here, right? Let's see here. There it is. And maybe that should have a debug on it, let's say. And there we go. Oops. Now we'll just have to update the Win32 one to actually use that additional debug one. And this would be called debug platform get memory stats. And then process state. When we're in internal, we can go ahead and say game memory, platform API, debug get memory stats, and there we go. I think I need an internal before that, don't I, though? Maybe not. There we go. Let's see here. Type def define should not have that semicolon. There we go. So inside our debug system now, if I wanted to, I could just print this out. So, you know, along with our sort of other heads-up display stuff. Oops. You know, here in this little dude where we do like whatever nonsense we've got here, I could now also get this information. So I could say like, all right, debug platform memory stats, mem stats equals, you know, plat dot, oops, dot debug get memory stats. And in theory, that would maybe work. Although it looks like, platform, sorry. In theory, that would maybe work. And then what we could do here is do like memory, you know, percent, what is it for longs? Is it LU? Percent L? I can't remember what the actual printout is for 64-bit integers. Interesting. It doesn't look like we actually ever set one. So do we want LL to be 64, or do we want just L to be 64? Like, which one do we want to print out? Is there a definition somewhere for this? Meow 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 meow. That's non-standard. Long unsigned int L. Long LL. Okay. How many bits is that? Does anyone know or care? Well, you know what? I'm going to make that be someone else's problem. I'm just going to say that minus L is fine with me. So let's just say that the integer length becomes 8 when you put an L in front of it. Happy birthday, everybody. That's just how that goes. Integer length And then that should just work, right? Because we already supported that up here where we did like the if length equals 8, get a U64 nonsense. We did that already. We did that. And so inside the debug code, memstats, I just want to print out some of these values that I worked so hard to get. So let's see. Debug platform memory stats. I want to do something like LU. Don't ask me why the block count is a UMM, but yeah. Blocks. Used out of allocated, right? Let's see. So if we print that out, I just need to put these in here. So that would be memstats, block count, memstats, total size, memstats, total used. So that's backwards. And off we go. So let's see if that works at all. I don't know if it does. 77 blocks, 340 megabytes used out of 414 megabytes allocated, and that's it. Most of that's in the asset arena, I believe. So you can kind of see that how these arena allocators are kind of nice too, because you can see that like there's only been 78 actual allocations there. But when that number was like ticking up and down and stuff, those were actually all tiny little allocations happening with we were just doing our push structs on. And it's nice that those are so cheap, right? That they don't cost us very much, right? All right. So there we go. Let's go ahead and go to the Q&A, shall we? I feel like we did some fairly efficient debugging today. I think you can all give yourselves a pat on the back for doing a nice, efficient debugging run. We didn't waste a lot of time. We zeroed in directly on the problem. Yeah, and eliminated it. The size long is greater than or equal to 32 bits. Long is greater than or equal to 64 bits. So does that mean that technically we should use LL then? Maybe. I mean, the problem is we don't want greater than or equal to 64 bits. We need it to be actually 64 bits. We need a printf specifier that's like, this value is 64 bits long. Please. I guess if it's our printf, we can do whatever we want, is one answer. But still, it would be nice if that was more rigorously specified somewhere. Meow. Meow, 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 meow. Windows is LLP64. Everything else is LP64. The only difference between the two is the size of long. Everything else, short int, long, long, is the same, says pseudonym73. You know, C sure managed to make its types complicated. I don't see any Q colons. No Q colons? I might be done early. Is there any plan on organizing the episodes in a manner such as worked on mandala on these episodes? Well, it's kind of hard, but because that's, I mean, maybe someone could write something that parsed the episode guide to do that. The only thing that there is for that at the moment is if you go on the YouTube, well, actually, I guess the easiest way to do that would be actually to do that. If you go on the YouTube, there are playlists. So, you know, you can get some semblance of that sort of thing by, you know, looking at the memory playlist, and there's, you know, stuff that's marked for memory specifically. And, you know, it's better than nothing. But is there any plan for anyone to like meticulously do it? Probably not. At some point when the series is over, probably someone could write a thing that parsed the episode guides markers that Miblo puts in there and turns those into an index of some kind. And that would probably be better because those are a little more detailed and like would catch things like, well, we didn't really work on memory allocation much on this episode, but during this one little time window, I did go in there and fix a bug that we, you know, because we had a bug that was in the memory system that just came up. And so we went and fixed it. So like, you know, maybe that could happen at some point too, and that would be a little better. At the moment, though, the only thing you can really do is use the playlist. They're the only thing that really has that has that aspect, I guess I would say. Shh. Miblo says that they're going to have category tagging in the new annotation system. I don't know anything about this new annotation system. But Miblo says they will have tagging, which sounds like the kind of thing. Would Handmade Hero get a version for Linux, or is it strictly a Windows project? If it's true, why not using Linux in work? Is it personal choice, or is it harder to debug something on Windows? So the answer to that question is, I've answered this many times before. It's because there's no the current market for games. You can't really make a go of it on Linux. Linux is almost zero sales for games, so you have to be able to ship on Windows as your primary PC platform. It's 95% of the market right now. So that's the reason I show development on Windows primarily. It's also true that debugging on Linux is worse typically because the debugging tools just aren't as good, unfortunately. Well, that's a little ambiguous. The visual debuggers are not as good. Some tools are better on Linux. Like they typically have better, like, you know, static analysis or bounds checking tools and stuff like that. You can actually get better ones sometimes on Linux than on Windows. So that's actually the case. But so yeah, if you're programming games, you kind of need your primary platform to be Windows. That's what almost everyone who runs your game will run it on. And so you have to be on that platform a lot and make sure that you know that platform well and get that platform nailed. So am I happy about that? No. Like, I don't like how Microsoft is always sort of acting as a very sort of greedy actor in this space and making life harder for developers to suit their own business interests. I don't like it, obviously. So I wish we could have had everyone move to Linux. But I just, don't know if or when that's ever going to happen. So unfortunately, we're stuck in that kind of reality, So yeah, the day we can get a viable game market where, you can sell over 50% of your sales come from Linux or something, that's going to be a great day. But, that day is not only not here yet, but doesn't even look like it's ever going to be here at the moment because there's been like no one seems to be able to making any inroads into making that happen. So, that's just the way it is. That said, if you do want the version of the game that runs on Linux, I believe people maintain one. There is a Linux port that people maintain of Handmade Heroes codebase. And I will port it to Linux when it's done as well myself, and there'll be an official one too. So there'll be plenty of opportunities to run the code base on Linux. It's just not ever going to be the primary platform for it because of the realities of the game industry, which, like it or not, are pretty much Windows-centric. And I don't know, that we're going to see that change, unfortunately, anytime soon. It would be nice if we did, but... Winners don't use drugs message needs to be added in the game's loading screen. I 100% agree. If you want to put log a bug in the GitHub for that, I would be happy to make sure that we get that happening eventually. Zillaresco, seems like the questions aren't polling in. Do you usually put your render update input processing in the same function like you have been doing? Yeah, I tend to break things out only when I find them to be important to break out. So I don't usually have a hard, fast rules for that. It's just whatever ends up being right for that project and the goals for that project. As time goes on, it usually becomes clear whether you want to do things in separate passes or whether you want to do them all in one pass. And so usually you don't have to really think very hard about that. It should be obvious. Edvin Holm, is the bending of the hero's body going to be like it is now? Looks a bit weird. No, this is not the real artwork for the game at the moment. So nothing that you see on the screen is how it will actually be. Moving from Windows to Linux, how much of the onus of making this change lies on the consumers versus Linux OS designers? Linux distros aren't normally ordinary user friendly. I guess I would say I don't know. I think that's too complex of a question. I don't know the answer to how you get people to move to Linux. I don't even know if you want people to move to Linux. I mean, Linux is kind of its own mess for a number of reasons. So I really couldn't tell you. I don't really have a strong opinion about that. Or like I don't think I know the way forwards and I can just say it. What do you think about free software? I don't really like it very much, I guess I would say. I like the idea that I guess what I would say is I don't necessarily disagree with where they're coming from, the sort of core concepts of free software. And I don't think it's a bad ideology. It doesn't happen to be my ideology. I think software should be commercial. I generally don't think code should be given away. I think it's hard to write. Very few people are good at it, and you should be able to make a living off of it. So I don't like the idea that source code is generally just available for people to use and reappropriate. But on the flip side, I don't like restrictionless software, so I don't like things to be completely commercial either, meaning I feel like while you shouldn't have to provide source code and allow people to use that source code just because you ship a product, I do think there should be restrictions on how you ship products that rein in the kinds of abuse that you see in a lot of domains, right? So if you look at some of the core tenets of free software, what they were trying to guarantee was sort of are along the lines of things I approve of or also want to guarantee, right? So, free software is typically what they'll say is, well, it's free speech, not free beer. The problem is the free beer typically comes with the free speech. It's really hard to have the free speech part without the free beer part. And so typically what you end up seeing with free software is that it pretty much does have to be distributed in a free beer kind of a way as soon as one person has paid for it once. There's not a lot of ways around that, right? But a lot of things they were trying to guarantee with the free speech side of free software, which was their goal, are good things, like the fact that if you buy a piece of software, you can continue to run it without the permission of the person you bought it from, right? That's a really big deal. The fact that you can install it on whatever hardware you're trying to run on, that's a really big deal. And what we see nowadays is definitely a lot of commercial software is getting very onerous and very restrictive of what you can do with it, and it's encroaching on basic usage that I would consider the core ways in which software should be provided, by law, required to work. I should not have to contact Microsoft in order to run Microsoft Windows on my laptop if I bought a copy of it, right? That's like policing has been taken too far or whatever. I should not have to update my Microsoft Windows. If I want to run an old version of Microsoft Windows, I should be able to do so. I should not have to have my machine connected to the internet in order to run Photoshop, right? As long as I've purchased a legal copy, I should be able to run my software. That's just a core tenet of software that I think should be enforced. And so to the extent that I part ways with the free software ideology, it's really just in that I don't think they figured out a very good way to enforce the ideals they were trying to enforce without making it very likely that programmers wouldn't really get paid the fair value of their work. That's what I think. But on the whole, I do tend to come from a similar place ideologically speaking, because a lot of the things that I see commercial software companies doing right now, I don't approve of. And that definitely don't fit with my ideology at all. So I guess what I would say is that's a fairly complete answer to it. Do I think like the GNU public license is a good license? Not really. Because I generally think software source code should be generally proprietary, and you should probably have to pay for it, and you shouldn't just be able to then use it for whatever you want to, as long as you also give away the source. I don't think that's very good in terms of getting programmers compensated for what they've done. And I also don't think it ends up achieving the ideological goals in the first place either, because if you take a look at, let's say you take a look at something like a Facebook or something, right? Closed platform, draconian about what you can do on it, tries to lock down things so that it all goes through their stuff. Bought Oculus and now controls that segment of the VR industry, locks games to that platform, blah, 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 right? None of that stuff would be considered in keeping with the ideological understanding of free software, right? But Facebook was 100% built on free software. There would be no Facebook today if it weren't for many Free Software Foundation products, right? I should say projects. And so if you look at the efficacy of the GPL or something like that, also it seems to basically do neither of the two things you might want it to do. One, to make sure that programmers are fairly compensated for their work, and two, in making sure that the ideology that it represents is forced upon those who would take advantage of that software. It does neither of those two things in my mind, right? So yeah, it's a complex issue. There's a lot of subtlety to it. I think it's not being done very well right now, if one were to look at it from my perspective, but that doesn't necessarily mean that it's bad from the people's perspective who are doing those sorts of projects. Maybe they are getting what they want out of it, I don't know. But hopefully that's a pretty complete answer. All right, I'm going to go ahead and close it up. Save everything there. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow along with the series, you can do so by pre-ordering the game on handmadehero.org. It comes with a source code, so you can follow along as we do stuff. You can play around with it. We also have a forum site if you want to ask questions. That's a good place to do it. A Patreon page if you want to support the video series. A schedule bot that will tell you when we're going to be live if you want to catch episodes live. And an episode guide you can go to if you want to catch up on old episodes. I was scheduled to be back here tomorrow, 8 p.m. Pacific Daylight Time. I do not know if I will be able to make it or not, so there may be a schedule update. Definitely check the tweet bot for that when you get a chance, just to make sure you don't show up here expecting one and not getting it. That's about it for today. If I don't see you tomorrow, I will see you the day after, either or. Thanks, everyone, for joining me. And until the next episode, I'll have fun coding, and I'll see you guys on the internet. Take it easy, everyone.